As vast and mysterious as space may be, the most fascinating world we know is the one beneath our feet, Earth. Oceans flow across its surface, an atmosphere rich in oxygen shields and nurtures life, and a powerful magnetic field guards us from the sun's fury. Most importantly, Earth is the only place in the universe we know that harbours life, and it is our home. But isn't it strange? Even though we live here, there's still so much we don't fully understand about this little blue world. What makes Earth so special? How does it work? And how did all the right conditions align to make this planet the cradle of life? In this journey, let's explore Earth from its shape and orbit to its atmosphere, ocean's deep interior, and even its faithful moon. Together we'll uncover the story of our planet, a story written across billions of years and still unfolding today. You may have heard people describe Earth as pear-shaped or egg-shaped. That might sound dramatic, but it's not entirely true. Earth isn't a perfect sphere, but the difference is subtle. Due to its rotation, Earth bulges slightly at the equator. The result? The equator is about 45 kilometres wider than pole to pole. This bulge also creates an interesting fact. The point farthest from Earth's centre isn't Mount Everest, as you might assume, but the peak of Chimborazo volcano in Ecuador. Though not as tall as Everest, Chimborazo sits closer to the equator, and thanks to the bulge, its summit actually extends farther into space. On average, Earth measures about 12 of these is in 742 kilometres in diameter, making it the largest of the 4 terrestrial rocky planets in our solar system. From space, Earth looks smooth and round, but up close, its mountains, valleys and trenches reveal a restless surface shaped by forces we'll soon uncover. For most of human history, people debated our place in the cosmos. Was Earth the centre of everything with the sun and stars revolving around us? Or was it just one body among many orbiting something greater? The idea of a round Earth isn't new. Greek thinkers, as early as the 6th century BCE, suspected our planet wasn't flat. But it was Eratosthenes around 240 BCE who proved it with remarkable accuracy. He noticed that during the summer solstice the sun stood directly overhead in Siena, southern Egypt, but cast a shadow in Alexandria to the north. By measuring the angle of the shadow and the distance between the cities, he estimated Earth's circumference within 5 to 10% of the true value. Imagine that with nothing more than sticks, shadows and geometry, he measured the size of the world. Centuries later, in the 16th century, the Copernican revolution transformed our view once again. Copernicus proposed the heliocentric model where Earth orbited the Sun. Johannes Kepler refined the mathematics, and Galileo's telescope observations sealed the case. Earth was no longer the centre of the universe. It was the third planet from the Sun, part of a larger cosmic family. Today, we continue to build on that legacy. Let's see what else we've learned about our home. Our Earth orbits the Sun at an average distance of 150 million kilometres, what we call 1 astronomical unit. At its closest, or perihelion, Earth is about 147 million kilometres away. At its farthest, or aphelion, 152 million. This elliptical path takes roughly 1 year, but not exactly. In truth, it's 365.25 days, which is why we insert a leap year every 4 years to keep our calendars aligned. Months were originally tied to the moon, with the word month itself linked to moon. But since the moon takes about 28 days to orbit Earth, and our calendars don't perfectly follow that rhythm, the two have drifted apart. Even our day isn't as simple as it seems. You probably think a day is 24 hours. But in terms of Earth's rotation relative to distant stars, a sidereal day, it's only about 23 hours and 56 minutes. So where do those 4 minutes go? Because as Earth rotates, it also moves along its orbit around the Sun. Each day it needs to rotate just a little extra to bring the Sun back to the same spot in our sky. That's why we measure solar days, not sidereal ones, but it gets more complicated. Due to Earth's slightly elliptical orbit, and its tilted axis, the length of solar days shifts by up to 30 seconds throughout the year. We solve this by using the mean solar day, averaging all these variations into a neat 24 hours. And then there's the slow tug of the moon. Tidal forces gradually slow Earth's spin, lengthening our days by about 2 milliseconds per century. It doesn't matter to us now, but hundreds of millions of years ago, days lasted under 22 hours, and there were around 400 days in a year. So timekeeping isn't as fixed as we imagine. It is shaped by the mechanics of space itself. Why do we experience seasons? Some might think it's because Earth moves closer or farther from the Sun, but that's not true. Seasons are driven by Earth's axial tilt, 23.5 degrees relative to the plane of its orbit. This tilt means that at different times of the year, sunlight strikes each hemisphere at different angles. In summer, the sun climbs high in the sky, its rays concentrated like a spotlight. Days are longer and more energy reaches the ground. In winter, the sun hangs low, spreading the same light over a larger area like a flashlight held at an angle. Here's a surprising fact: Earth is actually closest to the sun in January during the northern hemisphere's winter. Distance barely matters compared to tilt. The sun's angle is what truly determines temperature. Throughout the year, the changing sun path can even be photographed. If you take a picture of the sun from the same spot at the same time each day over a year, you'll get an analemma, a graceful figure, 8 in the sky. Its shape is the combined result of Earth's tilt and elliptical orbit. Every planet has its own analemma, each a fingerprint of its motion through space. One of Earth's most vital features is its atmosphere, composed mostly of nitrogen 78% and oxygen 21%, with traces of argon, carbon dioxide and water vapour. It forms a thin but life-sustaining veil around our planet. Within it lies the ozone layer, absorbing harmful ultraviolet rays and protecting life at the surface. Without it, stepping outside would be far more dangerous. The atmosphere also shields us from meteors, burning up countless small rocks before they reach the ground. But perhaps its most critical role is moderating temperature. By trapping some of the sun's heat, Earth avoids becoming an icy 18 Celsius world. Instead, it maintains an average of about 15 Celsius, a climate where liquid water and life can flourish. That water cycles endlessly between ocean, atmosphere and land. Sunlight warms the seas, lifting water vapor into the air. It condenses into clouds, drifts across continents, and falls as rain. Rivers carry it back to the oceans, and the cycle begins again. Along the way, water erodes rock, nourishes plants, and sustains every living being. The atmosphere and hydrosphere are intertwined systems, keeping Earth's surface dynamic and alive. Covering over 70% of Earth's surface, the oceans dominate our planet. They may seem shallow compared to Earth's size, but taken together, they are immense. If Earth's surface were perfectly smooth, water would cover it in a global ocean nearly 3 kilometers deep. But our world isn't smooth. Its surface is constantly reshaped by plate tectonics. Earth's crust floats atop a hot, convecting mantle. Plates shift, collide, and pull apart, forming mountains, trenches, earthquakes, and volcanoes. To us, these events can be catastrophic. Yet, in the grand scale, they refresh and recycle the planet, renewing soil, cycling carbon, and shaping habitats. Plate tectonics are rare in the solar system. Venus and Mars show little to no evidence of active plate movement. This makes Earth unique, a planet whose restless surface helps sustain life. So while tectonic shifts can be destructive in the moment, they are also a vital heartbeat of our living planet. Beneath the crust and mantle lies Earth's core, a realm of extremes. Mostly iron and nickel, it makes Earth the densest planet in the solar system, averaging 5.5 grams per cubic centimetre. The outer core is molten churning, like a vast ocean of metal. The inner core, under crushing pressures of 360 gigapascals and searing temperatures of 6,000 degrees Celsius, is solid. Together they form a natural dynamo. As molten iron flows, it generates a magnetic field, an invisible shield that envelops the planet. This magnetic field deflects solar wind streams of charged particles from the sun that could otherwise strip away our atmosphere. Instead, they are funneled toward the poles, colliding with atoms in the upper atmosphere and igniting brilliant auroras. Green curtains of light shimmer where oxygen glows, a living display of the cosmic forces that protect us. Without the core's dynamo, Earth would be far less hospitable. Earth's story wouldn't be complete without its companion, the Moon. Relative to its planet, it is the largest moon in the solar system. Its presence has shaped Earth's destiny. We see it as a glowing neighbour, close enough to admire with the naked eye, but beyond beauty, the moon exerts real influence. Its gravity pulls at Earth's oceans, creating tides. This tug even flexes Earth's crust slightly. Some scientists believe these tidal forces may help keep Earth's interior active, fueling plate tectonics. Without the moon, our nights would be darker, our tides weaker, and perhaps our planet less geologically dynamic. It is both a spectacle and a silent partner in Earth's story. When we step back and consider everything: oceans, atmosphere, tectonics, magnetic shield, and the moon, it's astonishing how many factors align to make Earth what it is. Billions of years of cosmic accidents and delicate balances gave rise to the only known world with life. 8 billion of us now share it, a species able to question, to wonder, and to gaze back at our planet from space with awe. Will we ever find another world as welcoming as Earth, perhaps? But for now, no planet is as beautiful, dynamic, and alive as this one. Earth isn't just a place in the cosmos, it's the story of us all. We've explored the extraordinary nature of Earth, from its shape and seasons to its deep core and protective field. Every part of this planet works together to create the only home we know. If you enjoyed this journey, let's keep exploring the universe together. Subscribe to Cosmic Compass for more stories of planets, stars, and the mysteries of space. Share your thoughts in the comments. What amazes you most about Earth? Until next time, keep looking up, keep wondering, and remember, the cosmos isn't just out there. It lives within us here, on this remarkable planet we call home.